All right, welcome back. So, we've all lived through the big leaps in wireless tech, right? 3G gave us the internet on our phones, 4G made it actually usable for video, and 5G is all about connecting, well, everything. But what's next? What's the big game-changing idea for 6G? Here's a hint. It's not just about getting faster. It's about giving our networks a brand new sense. So let me just ask you this. What if your network could actually see? And I don't mean with cameras. I mean, what if it could use the very same radio waves it's already sending out to sense the physical world around you? That's it. That's the revolutionary idea right at the heart of 6G. And that brings us right into our first section, 6G's sixth sense. Because this time, the big leap forward isn't just about downloading movies faster. No, 6G is being designed from the ground up with this new built-in superpower, a genuine awareness of the physical world. And look, this isn't some wacky, far-off idea for the future. There's a huge consensus coming out of the big industry workshops. You know, the ones held by 3GPP, that's the standards group that basically writes the rules for all mobile tech. And experts from all over the world are saying the same thing. Sensing has to be a day-one functionality for 6G. It's not an afterthought, it's being baked right into the core of the standard from the very beginning. Okay, so how in the world does a network see? That's what we're tackling in Section 2. Seeing with radio waves. We're going to break down how these invisible signals can actually be used to paint a surprisingly detailed picture of everything around us. The best way to think about it? It's kind of like a bat's echolocation, but for your cell network. So it all starts with the real basics, like measuring distance, or what engineers call range. The network sends out a radio wave, and that wave bounces off an object. Let's say it's you walking into a room. By timing with incredible precision how long it takes for that echo to come back, the network can calculate exactly how far away you are. The principle is just beautiful in its simplicity. The time delay of the signal tells you the distance. It's as simple as that. But you know, it's not enough to just see where things are, you also want to see how they're moving. And that's where something called the Doppler effect comes in. You know that sound an ambulance makes as it passes you, how the pitch goes from high to low? That's the Doppler effect with sound. And it turns out the exact same thing happens with radio waves. As an object moves, it slightly changes the frequency of that returning echo, and this Doppler shift tells the network precisely how fast that object is moving. Pretty cool, right? But how detailed can this picture really get? Well, this is where 6G's raw power really comes into play. It's simple. The more bandwidth you have, the sharper your vision gets. So with just 10 megahertz of bandwidth, your resolution is about 15 meters. I mean, that's pretty blurry. You could barely tell a car from a person. But jump up to 400 megahertz, which is totally in the ballpark for 6G, and bam, suddenly your resolution is less than half a meter. You go from sensing something is over there to seeing the specific movements of a person's body. It's a total game changer. So this leads to a pretty important question. How do we actually do this? I mean, are we just going to stick a separate radar unit on every single cell tower? No way. The goal is much, much more elegant than that. And that brings us to Section 3, in integrated reality. The whole idea is to build this sensing superpower directly into the communication network itself. And right now, there are basically two main approaches being explored to make this happen. On one side, you have JCS. That stands for Joint Communication and Sensing. The idea here is to cleverly repurpose the communication signals we're already using and get them to do double duty for sensing. Think of it like a really smart software update for the network. A great example is using your Wi-Fi signals to figure out where you are inside a building. Then, on the other side, you have ISAC, Integrated Sensing and Communications. And this is the true 6G vision. It's a system designed from the ground up, from day one, to do both jobs perfectly. One is kind of hacking the old system, the other is building the perfect new one.
Now, I know what you might be thinking. This all sounds a little bit like something out of a sci-fi movie, right? Well, the amazing part is, it's already happening. It's being proven out as we speak. So let's dive into Section 4, the world in high res, and check out how we're moving from just an idea to actual proven concepts.
And let me be perfectly clear about this. This technology is already being tested. All over the world, researchers and engineers are building these proof-of-concept systems right now. And honestly, the results they're getting are just astounding. I mean, just look at this quote from a recent European Union 6G sandbox project. The AI model enables sensing of humans in an indoor scenario, leveraging standard compliant 5G signals. So, what does that actually mean in plain English? It means they are using the 5G signals we have today, right now,
and combining them with AI to understand exactly what's happening inside a room without a single camera.
And what can they actually do? Well, they've already proven they can do presence detection, just knowing if someone is in the room. They can do positioning, tracking a person's location as they move around. And get this, even gesture recognition, identifying specific hand or body movements. Just imagine a smart home that doesn't need any creepy cameras, but it can tell if an elderly parent has fallen down and needs help just by sensing the disturbances in the ambient wireless signals. That is the kind of power we are talking about here.
And here's another amazing proof of concept. This one uses a technique that essentially turns our normal communication signals into a powerful kind of radar. Now, the process on the screen looks a little complex, but trust me, the idea is really simple. The system takes the standard data signals we use every day, sends them out into a room, and then intelligently processes all the echoes that bounce back. Through a few clever processing steps, it analyzes those echoes to find objects and can even build what is basically a radar image of the environment. It's literally turning data into vision.
And what has this already been able to do? Well, it can easily detect people walking through a room, no problem. It can track a hovering drone with incredible precision. But this is my favorite part. It is so sensitive, it can even sense the tiny, tiny vibrations and disturbances in the air caused by the spinning blades of a fan. I mean, that's the level of detail and sensitivity we're actually achieving. It's just incredible.
So, okay, where is all of this incredible technology headed? Well, 3GPP, that international group that sets the standards, has already started prioritizing some really key use cases. They're focusing on big, important stuff. Things like detecting unauthorized drones to keep our skies safe, monitoring patients at home for better healthcare, enhancing the safety systems for autonomous cars, and even spotting dangerous objects on factory floors or roadways. These are the real-world problems that 6G sensing is being built to solve.
And all of this brings us to our final section, our sensing future. Because what we're really talking about here isn't just another tech upgrade, it's about creating a fundamentally new relationship between our digital lives and the physical world we live in. If there's one thing you take away from all this, it should be this. 6G isn't just a network that connects us to the internet faster. It is being designed from its very DNA to be a network that is fundamentally aware of the world around us. And that really leaves us with one last massive thought to chew on. What actually happens to our society, to our technology, to our everyday lives? What happens when our digital world can finally truly sense the physical one? The possibilities, well, we're just barely beginning to scratch the surface.